Hey guys, how's it going? Welcome to another episode of Ferris Makes Demos. This is the first time I've streamed in a few weeks, as most of you know, because of revision. I'm guessing that's why quite a lot of you are here. I took a bit of a break from streaming so that I could work on our 64K called Dope on Wax by my group Logicoma. And I'm very pleased to announce, also as most of you guys know, that we got first place in the PC 64K compo, and I am absolutely thrilled and just ecstatic that that happened. We worked really hard on this, did a lot of new tech, and I'm a little bit overwhelmed about it, to be honest. Like, we've wanted to win revision for a long time, and we've worked very hard to build the things that we build, and I'm getting a little emotional about it, but it's absolutely amazing. And so I want to thank everyone who voted. I want to thank everyone who watched the intro and everyone who has enjoyed it. And I also want to thank the people that gave some constructive criticism. Much appreciated. I'd also especially like to thank everyone else in the competition who made incredible entries. I left the compo just feeling amazed and humbled and very happy that it was so strong. And had no idea who would win, and that's a really good feeling. I think that's an awesome sign for the demo scene and for 64K in particular. And yeah, it was just really cool. So yeah, thanks so much for the amazing experience, and there's so much more I want to say about how amazing it was, but we'll get to some of that a bit later. So yeah, Dope on Wax is the intro that we made. We're going to watch it in a second. Before that, I want to mention some other things that were really cool too. Another part of this Easter party that happened was the Meteorics. Meteorics is an awards show to celebrate the best productions in the demo scene from the previous year. My group Logicoma worked very hard last year, and we were lucky to have been nominated in 3 categories with 3 different productions. We actually got nominated for Best Soundtrack and Best 64K for 2 productions. And that was Trash Panda, which ended up winning Best 64K. And that's this meteoric statue that I have right here. Absolutely thrilled about that. Thank you guys so much. The other one that we were nominated for the same categories, Best 64K and Best Soundtrack, was Bros Before Foes, which we did with Pooh Brain, in particular Tropical Trevor, who did basically all the visuals in the entire thing. Awesome collaboration, and we will definitely do more of those. But that won Best Soundtrack, which we're, again, super thrilled about. I think I always feel bad when I go up on stage and say something about these kind of things, because I usually just get really kind of emotional and overwhelmed and a bit surprised. So if I don't say enough or whatever, just I hope it doesn't come across as that I don't care or anything, because I very much do. It's very much appreciated, and we're absolutely thrilled about that. We also got nominated for Best Visuals with Iota. Which I think Nobi ended up getting that one, which was awesome. So that was really cool. Yeah, absolutely incredible experience. Thank you to everyone who puts on the Meteorics. It's very much appreciated. We were a little bit surprised that we won Best 64K in particular, but I'll be honest, I don't think it's undeserved. We worked very hard last year to make the things that we made, and we're extremely proud that that was recognized, and that we got the nominations, and we were lucky enough to be laureates in those categories. So yeah, I'm I'm absolutely overwhelmed. And also after the party, the response to our new intro and everything has just been extremely positive. My phone has been blowing up constantly for the last day or two with Twitter and stuff. And of course, as I normally do, I'm very much obsessively checking Poet to see the comments, and it's amazing to see so many nice words. And it's definitely one of the more emotional years for me, just with this especially amazing like 64K fam kind of feeling, because like so many people did such great entries. And I mean, obviously like Conspiracy and Mercury didn't enter, and they were obviously missed, but I think we showed that the rest of us are capable of making cool things too, and that 64K is not dead without them, and they're not even gone. They just didn't enter this one year, so there's always next year too, and very much looking forward to the amazing things that they will surely come up with in the future as well. So Yeah. Also, I want to thank everyone who put on Revision. It was an amazing party. Things felt really smooth. I guess I can only say positive things about that. Yeah. Still a little bit emotional. But yeah. Anyway, I'm just really, really, really happy with this whole thing. Amazingly positive, just feeling really good about stuff. Also, a lot of the other 64Ks used both our synth and our packer, as did a bunch of the executable music entries. I need to give an extra shout out to Hoffman for really making that happen and really getting this thing in people's hands. That's really, really cool. And I think it's awesome that people were able to make cool things with these tools. Yeah. I do feel, though, that I need to point out a couple things that were a bit disappointing to me this Easter. And this isn't an easy thing for me to do because I like to think of myself as a person who is fairly diplomatic and think of myself as someone who I generally try to be positive and I try to be uplifting and I try to be helpful to people. And the demo scene, especially for me, has always been really, really positive and really kind of reflected those things. I've been in the demo scene for a long time, maybe 13, 14 years, and I've made a lot of really bad things, but I've had a lot of fun doing that, and I've always tried to push myself in some way or another in everything that I make, and I want to encourage other people to do the same. And that's kind of why I feel like I need to point out some of the things that did disappoint me this Easter, because I want it to stay that way. I want the demo scene to be the demo scene that I kind of cut my teeth in, and the demo scene that I want to still be a part of. So I'm not going to name any names, and I'm just going to mention a couple things, but I just feel like they need to be mentioned. So there were some comments made before the Meteorics to myself about things, in particular that the nominations were really strange or unfair, or that it was weird that a lot of them went to one group. And I don't really think that was fair to have been pointed out to me or said to me in a way, because we worked very hard last year, and I think that our nominations were deserved, frankly. But I mean, that's okay. I could deal with that, but it just wasn't very nice to hear. But I think the most disappointing part was that the same person, who I think was mostly just upset that they didn't have an entry, they came to us after a lot of us, after the 64K compo had finished, we were all standing together, and they made a comment along the lines of, we really should have won this. And I think that that's extremely unfair. I think it's unfair to not only us, but just everyone in the compo that had put in so much effort and made some amazing entries, especially some of the newer and younger sceners, which very much represented this compo. And they super stepped up and really gave it their all and made some incredible, incredible productions. I think it's blatantly disrespectful to say something like that, especially when most of us, honestly, are just working our asses off to even be at the same level that some of these other guys are at. And we know it's hard to not have an entry, and especially when you hold back your entry to make it the best thing possible. Like, I know that's hard, and I think that's awesome that as an artist that you did that. But I just don't think that that's a fair comment, and it really disappointed me, and it really bugged me. There was a member of another group as well that didn't enter that also said, "Thanks for sucking the least," which I hope was a joke, and my gut feeling is it kind of was, but I also don't think that was fair, again, to us or any of the other people that entered. Again, we're just trying to keep up with you guys, so just a bit sad. This wasn't the only time that I've seen this kind of behavior. At Nova, for example, there was a really disappointing incident where someone, a teenager, in fact, made an incredible wild entry, made this amazing thing, and while the video was being shown, it was being booed on the big screen and given the middle finger by someone who I would consider should have been a pretty mature demo scener. And that was very hard for this young person to go through that. But the reason I bring that up as well is because this particular teenager who made this amazing thing, they came back to revision and made at least 2 entries. And that to me is amazing, because that's someone who I think is going to be kicking all of our asses in a couple years. And I think it's really cool that that person didn't let that get them down and are coming back and just making even more and more amazing things. So again, I really don't want to mention anyone by name, but I'm really proud of that person for continuing to make amazing things, and I hope that they continue to do so in the future. Yeah. So that's just some stuff I want to say, and I really don't hope that doesn't come across as like I'm particularly bitter or anything, because again, this Easter was incredible, and my entire time in the demo scene has been incredible, and I just want it to stay that way. So I want to bring up these things. I think it should be pointed out that this was not particularly good behavior, and I just think that we can all do a little better, especially those of us that have been around a bit longer. I just think we can do a little bit better. Luckily, again, the demo scene has done better as a whole, and these few incidents really don't even come close to representing the majority of my experience in the demo scene, and my experience especially this Easter. Again, I just think it's extra important for those of us who've been around a long time to consider how we come across and try to set good examples for the up-and-coming people who, again, are going to kick all of our asses in a year or two anyway. So, yeah, I just think that's really cool. Yeah, so again, super positive experience. Had an amazing Easter, and I hope all of you guys did too. Again, extra shout-outs to especially the other people in the 64K compo who made incredible entries, as obviously very subjectively that made the experience very special to me. And there's nothing I love more than watching a compo with everyone like that, and then getting together afterwards and just talking about it, like talking about the effects we did and talking about what was cool, and giving each other feedback. And I just think that's really awesome. Obviously there were other amazing entries too there, especially the Amiga compo is particularly strong. Obviously have to give huge shout outs to the Black Lotus for releasing an incredible Amiga 500 demo after like 3 or 4 years of working on that thing. It was really, really cool. And somewhat disappointingly, I really didn't see much of Hoffman this year. So WOBBLE couldn't make it, which is also quite unfortunate. He was very much missed. He's become a pretty integral part of the demo party experience. But yeah, me and Hoffman sat next to each other and barely saw each other because we were both so busy with other things, whether it was the intro or talks or commenting on Shader Showdown or whatever. So that's a bit sad, but I mean, we'll always have more parties together and we'll always make more things together. So it's pretty cool. Anyway, I started this a bit more emotionally than I would have liked, but anyway, thanks you guys for listening to me say that. Again, I really don't want to come across like that's my impression of the demo scene, because it's totally not. The demo scene's an amazing place, and even some of the actions that I mentioned earlier, those people are normally not like that, and they're also amazing people, and yeah, I really have nothing but positive things to say. But yeah, this is all awesome. I should say hi to people in the chat. This is a long list this time, but I'm going to go for it. Zokwar, Dark Second, Bitnenfer, Cyberpunk, Daniel Collin. By the way, Daniel Collin is emote of TBL. Congratulate him on the amazing prod. Black Pond, good to see you. Mad Moose, CPDT, amazing 64K. Thank you so much. Hedgehogs are really cute. Spaghetti about it. Dude, you have my favorite handle ever, by the way. Salens, Ixion PB, Alkama. By the way, Alkama, I loved your 4K. That's the cutest thing I've ever seen. I hope that's not the last one. Shopical Trevor, also amazing entry. Really cool 16K, especially the texture work. Caroline, hey. Oh, she's not watching anymore. Evil, good to see you. SK Thess, Wobble, of course. Wistertobe. Let's see. I'm probably missing names now. Sir Skidmore. Flopine, good to see you. Steltech, thank you so much for putting on the party. It's been awesome. Jacob Mishka, thank you for the sub. And also good to see you. It has been a while. Max Low, I believe you're the compression person I met, right? It was nice meeting you. If so, otherwise, I apologize if I'm misremembering. Ebunix, how's it going? Some new names. Niner Delta. That's not a new name, but Moliv. Luna, of course, also amazing entry. And congrats on the new group name. And also, thank you for doing the breakdown stream. That was really appreciated. I really enjoyed watching that. Let's see. And of course, Hoffman. Salens. I think that's everyone. Tropical Trevor says, Ixion deserves shoutouts for pushing me into that texture work. Good. Shoutouts to Ixion for that. Okay, I think... Oh yeah, Maxo is the one porting the Wavesaber Linux. That's cool to hear. Thank you so much for looking into that. Anyway, probably about time we talk about the demo. So I think before anything, we should actually just watch this. So I'm going to put this on. I'm going to mute me, and then we're going to go through it. Would help if I actually rewound this in the tool. Yeah. All right. So let's just watch this. So that's the demo. personally, I am pretty proud of this. I'm not gonna lie. Trey Guy, fantastic work. Is demo title reference to Complex's 1995 Dope demo? Nope. Nothing like that. Just something that we thought was cool. Yeah, Darth Shader isn't credited in this one. He's asked not to be. Going forward. Let's see. Maxlow, is it a mixture of ray marching and polygonal data? No, it's all polygons actually. Thanks, guys. I think this is, of all of our demos, I think this is the one where we've done the most tech between this one and the last one. And I think it really shows. And I think, like, I especially really push myself to, like, push polygon tech and just try to make this look as not size limited as possible. So a few new things that we did a couple new features in the synth. We did mesh support, mesh compression, with subdivision on that as well. And we did the isosurface stuff at the end of this as well, which I hope to improve and turn into actual fluid sim stuff, because right now it's just some SDF crap. And it's also way slower than it should be. I'll talk about why in a bit. What else do we do? I'm not really sure. No. We definitely didn't abandon Wavesaber. We just did some new features in the synth. And then, yeah, new packer. This was finally the first intro where I got to use our new 64K packer. I think there were 3 other entries that did as well. And thanks, guys, for giving that a shot, by the way. I'm glad it saved you all some bites. But yeah, I think I worked on that for like 3 years, and I'm in the middle of making several blog posts about how that works. I've talked about it a lot, mostly in different streams that I've done, so we'll probably skip most of that here. But I actually want to talk a little bit about the demo tool here, because I think a lot of you probably haven't seen it. So this is my demo tool called Demotivation, and there's a couple different parts here. Oh, that's awesome, Luna Sorcery. I'm actually shocked that it was about 4K. That's insane. Yeah, Wavesaber's not going anywhere. It's, if anything else, we'll just add more and more stuff to it. We have some plans to change some fundamental stuff, but not going to happen anytime soon. We've got more than enough on our plates. Anyway, so this is Demotivation. There's the main parts here are the viewport on the right here. Then there's this operator grid on the left, and then the profile down at the bottom. Of course, these are dockable to whatever. It's just used as cute. So this is just showing like how long things in the frame take, and of course, there's too many things to list here. This is 60 FPS and this is 30, so the demo goes somewhere between there depending on the effect and what's going on. It's also a bit slower while I'm doing a capture with OBS like this, but it's still pretty good. I'm running on a GTX 1070 from a few years ago. I think I bought it right after Tursock 2016, where we did Elysian, which is the first demo with this tech, or at least the first incarnation of this tech. Anyway, just like quick lightning round on how this works. This is actually essentially a visual programming language, and this dictates everything that happens on the CPU. The main job of this code here is this all compiles to a function that gets called every frame by the demo that actually renders everything you see on screen. So you can see here, like, it'll clear this, turn on depth testing, actually turns off depth testing, figures out the width and height, so it like changes the aspect ratio, loads a couple meshes, and then calls the rendering pipeline. And the rendering pipeline's over here. We have typical stuff, chromatic aberration, glitch, a lot of stuff to do, screen space reflections, and bloom, and depth of field, vignette, film grain, all kinds of stuff. More stuff on the bloom and the depth of field. This is stuff for screen space reflections. And most of this is stuff like bind a shader program, or load a mesh with a certain amount of subdivisions and a certain amount of quantization, or set a uniform, or draw a primitive. So it's, or call subroutines, and then there's subroutines in these things as well. So essentially the way we work is that I sit here and build a renderer and some other things in this as a mix of this, and then of course external shader files and other assets. Mostly shaders is what we have here. Dope on wax assets. And there's a lot of different like sets of shaders for different effects. And then most of this is just keyboard driven. Of course, it has unlimited undo, which is very useful for our workflow. And then, of course, some of this stuff also like you can require to get sync tracks. And then that will come from Rocket, which we also run at the same time. The use of Rocket, I think I've covered that a lot in other like streams and other breakdowns. So probably best to check that stuff there. But I think YX also did a good description in their breakdown of their demo, which is nice. But essentially this just allows us to like change parameters over time and also control the music, playback of the music while it's in the tool. And right now, like all the cameras are rigged to use Rocket, but if, for example, I went to this scene, which I think is called Tube Logo, and I go and swap out the camera with like this one, then I can like click around and move around there. So this helps us kind of figure out what the angles are going to be and sort of figure out what things are going to look like before we actually rig it in the sync tracker, so that we get kind of the best of both. So typically, I think most of my time is spent actually before anything is even rigged in Rocket at all with those kind of cameras. And then we sort of start figuring things out. So I guess I should start just kind of going from start to finish and talking about how these different effects are done. A lot of them are very simple. I think generally that's kind of the stuff I do, is I try to just make things that look really cool. And a lot of the time the implementation ends up being fairly simple, but as long as it gets the kind of look that I want, then I'm generally pretty happy. This particular effect, this was an idea I had. I found some stuff on Vimeo that looked very, very similar. And I was like, oh, I really want that, like these flowing kind of pipe things. And I really wanted that to build into our logo. And so actually the way this works is it's relatively straightforward. I'm going to open up Paint here. By the way, again, all of this is polygons. And in fact, this is done mostly in a geometry shader. Like we have a primitive in our tool that's just a point primitive, and it just is like a dummy point. And so if we want to draw like 1,000 points, we just tell the GPU to draw 1,000 points, but we actually don't give it a vertex buffer. So it just ends up being like undefined what the inputs of the vertex shader get, but then we can dispatch things in like the geometry shader to expand that out. In particular, each one of these tubes has like a number of segments, which is like because it's essentially a cylinder. And so the idea is that we're going to generate a bunch of points on some kind of curve. So in the default configuration, these are supposed to just be points. The default configuration, of course, you would basically draw out the logo. So there'd be like 3 different rings. And so we draw different tubes. So we draw like, I don't know how many points, but it's essentially the amount of points, the amount of tubes times the amount of segments. And we choose based on the index of those in the shader, whether or not it's on each one of these different rings, and also how far along it is, like which segment that will be expanded to. So each point gets expanded to essentially a segment of the cylinder. So something like this, where it goes from this point to what would have been the next one. And the math is just such that we just end up placing the points. So given a certain point on the curve, we know where it is, we know where the previous one, and we know where the next one is. And so essentially we orient a disk around that, and then we want to figure out that disk and then what the next part of the segment's disk is going to be, and then generate the connecting segments here, just in a circle. And so we need to find out, of course, the direction, like the orientation of these disks, which ends up being pretty simple. I think we take like an up vector and then the vector pointing to this, and that gives us like the side vector here, and then we cross those and we get the third vector. And with those basis vectors, we can make a matrix. And then with that, we just output the points along that disk. And so we do that. So we calculate the matrix for the current disk and the next one, and then we just connect the points. The code to that, I think, is relatively simple. We have here, segment point. So this is what, given like which one of these segments we're on, it gives us the point in the middle of that, where that is. We also get the segment material, which grabs the segment point and then the one previous and the next one, so that we can orient the disk. And that gives us a matrix that represents that orientation and translation. And then, exactly, I'll call my extrusion is the new ribbon. And then we literally get, this is actually stuff to pinch the ends too, but that's not that important. But we get the starting one and the next one, and then we just connect all these segments in a little circle. So it's fairly straightforward. And then to actually select the points, this is also, I think, a bit simpler than it looks, which is kind of the point. It's literally just some sinus stuff. So we have a couple parameters here. Let me go to this shot and then just tweak some of these. So if I open tube logo here in Rocket, we have the time offset, which is like how far along it is in time. That kind of makes sense to show in a second. So if I reduce the tube length, this is how long these different segments are. And now when I change the time offset, you can see it kind of moves around, kind of wiggles. We have the tube count, which I actually modulate depending on the shot as well, because sometimes it works better with more and sometimes it works better with less. Like in this shot, you want less because then they Z-fight less. But there's still more than I would like, and there's a bit more aliasing that I'd like. I would like to look into some temporal solutions for this, but right now I've stuck with FXAA. I think this tube time as well is actually the one that I was trying to describe, where it kind of goes around in a circle then. We also have the thickness of the tubes, which I can modulate. I don't think I ever actually did modulate that in the demo. There's stuff like changing where this highlight is in the background, and that we use to make the background look like it's more dynamic in different shots. And then we have things like, so it essentially generates points on a circle, and then we have a plasma going in X, Y, and Z. And that's what I call the distortion. So we can change this distortion amount to a lot, but typically it's quite small. And then there's this dist V scale, which is just like, if you take the point on the circle and you multiply it by some scale and then you give it to the plasma, this is what that scale is. So 1, 2, 3, you can see they get essentially lower or higher frequency for these changes. And then there's a like distortion time offset per tube, and this just determines how out of phase those plasmas are. And with that, I think that's mostly the parameters here. Then we have enough to be able to build these shots. So kind of as it's doing these more flowy shapes, we have like the distortion a lot. So you can see these are still the 4 components of the Logicoma logo, just with a lot of distortion. And then we do a couple shots where we just keep the distortion really high just to make pretty shots. And none of these shots are coherent. Like these aren't the same parameters here as in here. They both just look kind of cool and they look like they're kind of the same thing, which is good enough. And then here, I very much intentionally started to make the logo recognizable, even though I knew most people wouldn't recognize it at this point. I just thought that like, if anyone kind of notices what this is going to be, then I've done my job. And then finally it comes together to be the full logo. And I think I could have maybe pulled that off better if I had, because here we're kind of looking through the back of it. Maybe if I had tilted that differently, that would have been a bit better. Like if I did 70 here or something. I'm not entirely sure. Maybe that would have been better, but anyway, I think this turned out really well. Maybe other than the aliasing, perhaps. I'm intentionally kind of going through this a little bit quickly because I know that I've got a lot to cover, and I don't want to make my stream too long. I think Flopine has another stream where she's going to go over like the shader showdown stuff, which is in like 20 minutes. So I like to get through as much as I can before that, but I'm going to go as long as it takes. Yes, Black Pond, the background is a rate gradient. Thanks, Evil. I appreciate that. And also there are 2 foreground gradients. So in most of the scenes, there's a background gradient, which is usually just gray. And then there's these 2 foreground gradients, which I kind of modulate over time for a lot of these. But there's this one down here, which is like purplish. And then there's the one up here, which is more kind of reddish purplish. And that actually ties a lot of the scenes together, just having those similar gradients. Instead of having the same ones on the entire demo, I copy and paste them for all the scenes, and then I just like make small adjustments. So they kind of fit the individual scenes better, but at the same time, they really give a more unified look to the whole thing. So yeah, so in this case, these gradients are all screen space. Very basic. And in fact, they also helped me debug one of the bugs in the VM that this JIT compiles down to, which is basically, I don't know if I mentioned that this grid thing gets compiled to actually x86 code in the intro. So we actually ship a bytecode in the intro, and then it gets compiled to x86. But I found out that there was a bug in our engine where if you change the depth mask in particular, that state actually wouldn't have been, the state would have been, or wouldn't have been restored properly. So then next time you affected the depth mask, it would have actually pushed the wrong state onto the stack. Like, it's kind of confusing, but essentially it meant that if I changed the depth mask in the scene, then later when it would render shadow maps, those would be completely fucked up. So that was annoying to debug. And in fact, I would have done this same trick in Trash Panda had it not been for that bug. That was actually in there for about 6 months. And I finally figured it out like a month ago. But yeah, so moving those around a little really helps to not make it seem like it's the same camera, because like here we have it up here, and then like in the next shot it's down here. And usually I move the background one. The foreground ones generally stay the same per scene, but they really just kind of tie things together more than anything else. I think that's basically all I have to say for that scene. It was mostly just a logo. I think if anything bugs me with this scene, it's the aliasing, and I really hope to fix that, but I think it's pretty cool. And I really love this too, because this is one of those things where I think we're really lucky to have been that people are recognizing our logo now, because this scene obviously doesn't work if you don't know that that's our logo. But if you do know, then it's really cool. So I really appreciate that. Like, again, I've been in the demo scene for a long time, but it really wasn't until Logic Coma that I think the stuff that I've made has really resonated with a lot of people. At least that's my impression of it. So it's really cool to be able to see that we have this kind of recognition and can take advantage of this like this. Toad it, Matt? Is that how you say that? Thanks for the follow. Hey, Aaron the German. Yeah, Elix as well. I mean, Elix had a lot of mixed reviews for stuff because we did some video compression for one of the demos, and I think a lot of people have... Anyway, I'm not going to get into that. Anyway, I'm very happy that we have the kind of, I guess, brand recognition to be able to pull a scene like this off. I think most 64K groups do at this point, because I think they've invested in making some kind of logo. Anyway, the next scene is maybe a bit more basic, maybe not. So there's a few really important components here with this scene. Essentially, we have some major parts. Let me remove parts and I can show you. So this one's called Bubble Boy, and I'll get to why that is. So again, I'll show you that there's these gradients here, the same ones that were in the other one. You can see really tying that together. There's also these sort of background objects here, and that's mostly just to fill space. I think these are just tetrahedra. There's a couple more things here. Background gradient, again, I think this one just stays in the middle. And then we have a few different parts here. So let's just get rid of all this. Boop. So we have this backlight, which is just a ring. I made a ring primitive in the tool, and this is actually kind of neat. It's a ring, but I turned the segments down to 3 and you get a triangle. And the way this is done is it actually renders, it's drawn with instance quads. So it does a quad per segment and then figures out based on like the inner and outer radius and the start angle and end angle. Cause like I can make this go to like 30 degrees. It's going to figure out where all that is and then just sort of align it on X and Y. And then this is just really brightly emissive. It's really all that this is. So that's that. And then there's the floor, and the floor is just a big cube. It has some like kind of scratchy material on it, but I think it doesn't really come across, and I didn't spend that much time on it. So I mostly just made it rough and added some perturbation on the normals. But the main point of that is really just to reflect everything and also catch some of the lights. So there's a couple different lights here. I think there's 3 of them in this scene. There's like a white one, and then there's this one, which is the red one, and then this one, which is the green one. And I'll take that out for a sec as I bring in the subject. So the subject is the statue, and this was mostly meant to show like the mesh compression. So this is a Venus statue. And hey, Spaghetti, thanks for the sub. Yeah, it's a cube, not a plane. Sorry, Bomba. Yeah, thanks, Alkama. Yeah, Dark Second, to be honest with you, I don't know why I love this purple triangle as much myself. I tried so many different shapes and so many different colors, and this is just the one that's stuck. In fact, I should be showing that. I should be showing some of these work in progress shots. I'm glad you said that, because I have a whole folder of these that I saved as we went along. and I really should be showing that. Logic Coma demos, Dope on Wax, Whip. Yeah, especially this scene, I tried a lot of different things. I tried this and 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 this, and that's something else. But I tried a lot of stuff, and that's just a fraction of what I showed. We'll get to a lot more of those, because actually there are several more I didn't show. I think this is the first test scene with this, and I started working on the screen space reflections. Some buggy shots with that. This was a deer head at one point. I still might use this in something else. I kind of like that. Lots of glitch, more deer head with the lights, more reflection stuff, etc., etc. Tried a lot of stuff. In fact, I think this scene actually started with the head model, and trying to make that look cool. Maybe. Actually, these are kind of cool in terms of what I was trying to do with this scene, which is that I wanted to kind of lean into having mostly low poly geometry. In fact, that was one of the kind of inspirations of this demo. Was Altera released a demo at DemoBit earlier in the year, and I really liked it. But I also thought like a lot of that would be appropriate for 64K as long as we kind of leaned into the low poly look. And so what I wanted to do was kind of mix this low and higher poly versions of the mesh to kind of really own that. And play with things like making them outlines, do extrusions, all that kind of stuff. So like really early on, I had these extrusion shapes, which are used later in the demo, and I kind of want to go over that then. Oh, and I actually have some really early shots here where like this was actually the flower thing in Trash Panda, but made out of deer heads. Lots more stuff that I'll get to. We try a lot of things in our demos. Anyway, we'll get to some of those later. Yeah, Luna, that was the Mara demo. I quite liked it, and I just thought that we could do something kind of similar. Obviously, we ended up with something very different, which is great. That's usually how it happens. Like we get inspiration from something, and then we end up taking it in several different directions as we get inspired by different things over time. I think that's the way it should be. Yes, Daniel Collin, I will go over the mesh compression. I'm going to finish going over this scene, and then I think I'll look into that. I'll talk about that. I think when we go to the deer head scene later, that's probably the best place to show that. Yeah, in terms of the meshes, these statues, I think I actually bought them. I found them with some, I probably should have credited them in the artists in the README, but I bought them with like essentially all rights. And I figured someone probably just took like high-res ones and decimated them, but they decimated them really well so that the low poly ones actually looked really good. So I think these are even called head still. And I think head high is this one. So for 0 subdivisions, yeah, we get that. 1, 2 is I think how high this one goes. No, I don't, Cyberpunk. I'm not that cool. The head model, I think there are 3 models that we ended up using in this. This one is the biggest. I think it clocks in at like 1.5K after compression, which is actually really good. And then there's the head model, which I think is about 0.5K. And then there's the deer head model, which I think is like 600 bytes. And that's really small for these. I'm extremely happy with the compression. Anyway, for this scene, you can see here this, and there's like actually another light source that I didn't mention here, which is actually a really cheap environment map, which you can see just kind of lights everything up a little as I bring this up and down. That just adds a little more to the contours. It's actually a really crap IBL thing that I failed to make in Trash Panda that just kind of looks cool anyway, so I keep it. Yeah, the deer head's really tiny. Anyway, adding back some of the lights, you can see like this light, its purpose is to kind of actually illuminate the subject. The other lights is just to bring out contours. So they're kind of like in the back, and they give all these really nice highlights. And most of the scenes in the demo, I would basically copy this one in that lighting environment and then start with that and kind of tweak things. So like the wax at the end has this light from this color. So that's kind of how that developed. Anyway, in terms of the layers of what we're actually showing, this is a mesh that is somewhat high poly, and then I go in and I extrude all of the different faces. And I think like here you can see they're all being extruded. And they get extruded so that the end is actually also shrunk a little bit, which I just think looks kind of nice. And so that's kind of the first effect that's happening here. But in addition to that, we have a couple more. So that's the solid part. And then this is the low poly part. So what this is this is the low poly version of the mesh. So it's the same mesh, but with like less subdivisions. So I think it has one subdivision, it looks like here. Or maybe this is even the original with no subdivisions. I'm not actually sure. But then it's basically the same thing, except it has a vertex shader that makes it like really bubbly like this. My plan was to have that, I guess, looking a lot different than it did. As you can see, there's no ambient occlusion, which is kind of a shame. That would bring out a lot of these details more, but that's something that I have to get to in a later demo. But I just liked the idea of having this like low poly version of it kind of bubble out of the main one. So that's pretty cool. PSNF said he remembers a talk from IQ about compressing 3D models. Yeah, what I did ended up being a bit better than what he describes. It's actually almost identical to what the Farbausch guys did in like 2003. It's the same paper. I just made it work for only triangles, and it turns out to work really, really well. At least with these really irregular meshes. A lot of the clever tricks, well, I'll get to that in a minute, but anyway, the last things here is there's this wireframe kind of thing, and this is a geometry shader that again takes one of the lower poly versions of the model, and it just makes a wire between the first two vertices of each triangle. And then sometimes I also have it also make a full triangle between those two, and I think it actually makes the front and the back face. This is all just done in a geometry shader, and it's all pretty basic stuff there. But this kind of gave that like frame around it, which I thought was really cool. So here, this is with and without. And then finally, there's the points, which are at all the vertices. And this is just adding cubes to vertex 0 of all the triangles. Like, it's really, really quite simple here. But I think altogether, this ends up looking really cool. And like, it's nice with the shadows kind of going on that. And I don't know. I just like how this looks. Sync-wise, I wanted this to kind of bubble up and sort of make it look like it's sort of corrupting more and more as the music gets like out of tune here, but we didn't have time to do that. I think that we will not do a final of this, by the way, just because I think I'm actually pretty satisfied with the result. Like all these things that I'm telling you that like originally I wanted to do this, like no one knows that I wanted to do that unless I say it. So it's not like it's really missing anything, even though I feel it might be. So I think I'd rather just focus on tooling that we need to make for the next stuff we want to do. Anyway, that's basically all the scene is. As you guys say, it's simple ideas, but I also think they're pleasing. It's a lot of stuff that I just like try and just kind of tweak over time and move between different scenes, and then something works in one scene, so I go and implement another scene, all that kind of stuff. So unconditional branch, how many columns do you have in Rocket? Let's count. I'm curious about that actually. So there's a scene 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 19, 20, 21, 22, 23, 24, 25, 26. 27, 29, 30. Is that 40? 41, 42, 60. I think that was 60, wasn't it? 70. 80. 90. 100. About 110. A lot of these are like duplicated though, because like I have a camera for each scene, which is kind of wasteful, but I just found that easier to organize. So something like that, I guess. Anyway, I'm glad you guys like the scene. I was worried people would think it was too simple, but I just liked it, so it stayed and it fit with the music. The next part is, of course, this like flashing thing with the music. This is literally just flashing some background stuff. I don't want to talk about what I wanted to do here. It works. Flashing the logo, and then we go into the next scene. Unconditional branch says, do you plan your intros, or do you just see what you come up with while working? It ends up being, we just kind of see what we come up with. Every so often we come up with specific shot ideas, which was just like, okay, we're definitely having that, like the greeting scene in Engage, or the Tubes logo scene in this one, and also the wax scene in this one, were things that I knew I wanted to do pretty early. But mostly we just kind of come up with stuff and play with stuff. I watch a lot of motion graphics, so it's like I kind of watch a lot of that stuff and think about what can I kind of take? Like, can I take the motion from this thing and the shape from this thing and the colors from this thing and kind of put it together nice? So like, I feel like I walk around a lot with stuff going on in my head and then implement when I kind of know what I want to do. But of course, a lot of it is also very organic, like putting something down and just seeing what we get. I would like to do some demos where we do plan it out, but I've had a lot of experiences, especially professionally, where I feel like that's really constrained what we're doing and really made things not very fun. So we'll see. Then there's this scene, which is called Pandicles. And that's because this is the same particles as the flowing triangle thing in Trash Panda, with a couple different additions. The first thing is that there's some rings in the back, and that's just some slowly rotating rings. Let's go over here, actually, to the Pandicles, which is here. And again, I think it's the same gradients on the top, which add a lot to this scene, it looks like. Yeah, then there's these rings in the back, and then there's the subject itself. And I think if I do this, we get none of that drawn. Yeah, so this is the ring. If I just play this, whoops, that's loud. The rings just kind of rotate, and they're just back in the depth of field. It's literally to just frame the particles, because if you just have particles flying around, it's really kind of hard to tell where you are. So you really want something to kind of ground where the scene is. And that's really all that those are for. The thing itself is drawn. So there's a compute shader that does all the particles. No, the rings were not meant to be a revision logo. It's just something I tried to put together. Yeah, it's balls touching, or as Slummy of Spaceballs mentioned, I didn't need that many blobs or that many vector blobs to impress people, but you know, what does he know? It's basically a compute shader that updates all the particle positions. It's really basic in terms of like how the particles actually work. There's some curl noise stuff to affect the acceleration of them, and then there's some other things to affect the acceleration, like to make them all go forward, or to make them all go like radially out. And it's a very basic feedback effect, which makes it really, really annoying to sync. I think I fought with that most of Saturday when I wasn't fixing that timing bug in the synth that I did for YX, which I'm glad I did too, because that would have helped a lot. I think that helped a lot with our demo as well. Anyway, I think the only really different thing here is how I got them to wrap around the mesh, as G Superlin points out, and that's actually really, really easy. So I actually did this at the party. I can show you what this looked like when we got to the party, which was this. This is a screenshot I took at the airport in Frankfurt as we were eating. And this, you can see it was still a simple shape like it was in Trash Panda, but of course I was playing with different colors. And it was about this time where I thought, like, I tried different shapes and I just couldn't get it to look different enough, so I thought it had to come from a mesh. So what I end up doing, it's actually really basic. The same vertex buffer that we have for the positions that we would give to the rasterizer, you can just bind the same buffer as a shader storage buffer. And so what I do is, I'll show you the code that does it. Let's see, Pandicles, in compute. In compute data layout, I bind the vertex buffer here, and I do this as 3 floats and not a float 3 or vec 3 to make sure I get the right alignment. That actually caused some really fun bugs. If you don't do that, I should have commented that. And then here, when the particle is going to respawn, where is it? I think it's actually here, spawn pause. We take the particle buffer position and we modulo that with the number of vertices, and we look up the vertex in the vertex buffer, and that's where we spawn the particle times some scale. That's the whole thing. So it's literally just binding that same vertex buffer as a shader storage buffer, which means technically we could write back to that and corrupt the data, which could be fun, but we don't do that. So it's literally that simple. And then there's a lot of things here that I tweak to make this nice. Obviously, a lot of things in the sync tracker about little flashes, little glitch things. Oh, by the way, this actually does render both the particles themselves and the segments between particles sometimes, which are not actually visible in most of the effect because, like a div, I went and turned this, where is it? Max line length to 0 at the second camera shot and never turn that back on again. So that was stupid. But it's fine. Yeah, the dark side of it, you can kind of see it, but only in this first shot, and then it's gone. It doesn't show up after that. Anyway, some things that I do here to modulate this. There's an acceleration amount, which is how much the curl noise affects the position of the particles. There's a death speed, which is how quickly they die. And then respawn. There's a time scale, which is how much, like literally a multiplier for the delta time. And that kind of makes it slow down like this. There's dampening, which is how much or how little their momentum is preserved. Forward acceleration is how much they go forward. Radial acceleration is how much they go outwards. And with that, you fight with that for a few hours and you get whatever we ended up with. In particular, I really like this shot. And there you can see also the green light from the earlier scene is also present in this scene. This shot I really like and how it like rotates after that. It's just a lot of playing around, and this was actually a real pain in the ass. I'm really happy with how it turned out, but it was super annoying to deal with. With the lines, let's see, because I would have to turn, let's say, I think I used just 1.5 for this, so if we use 1.5 for all the other ones, we can see how it looks. Yeah. I can't see who just followed me. Nemixib? I'm not going to try and say that. Thank you so much for the follow. And turn this down. I mean, I don't think we're missing anything by not having the lines, really. Especially not when they're turned down that low. With just the lines, it looks like this. So kind of cool, but yeah. Basically all it is. And then, of course, the sphere here, actually, I don't have like a sphere primitive in the tool. I actually import an icosahedron, and then we subdivide that down to different levels for spheres. So again, I guess that's actually the fourth mesh that we have is an icosahedron. It's kind of funny. But yeah, again, that's basically all there is. This is just drawn with instancing, and then the particle buffer also contains like what color the particles are. The particles, when they're spawned, they get a different color depending on some function of their spawn position, which is why we get these stripes. The bytes for the... thank you so much. Really appreciate that. The bytes for the icosahedron is like 30 or something. It's tiny. It's a very regular mesh, so it compresses really well. That's mainly it for that scene. It's a lot of sync. Pain in the ass. But I think it turned out really well and fit really well with that part of the music. I'm sorry, FMS Cat, but thank you so much for joining. Really a big fan of your work, by the way. I loved your 64K from last year. Was it last year? I think it was last year, the JavaScript one. Thank you so much for catching this. That means a lot. This scene is... Thanks, you, Superlin. Spent a lot of time on it, obviously. SK, this is how do you usually collaborate? I could probably talk about that. In this demo, I felt like, because normally we sync a lot at the end together, and we didn't do so much of that this time, mostly because WOBBLE couldn't be present, and Hoffman was so busy with other things, as was I. Thanks, FMS Cat. So normally I kind of do the visuals in a bit of a bubble, but I like post screenshots all the time. So like this demo we worked on for a couple months, since sometime in February, and I was posting screenshots every few days. And then the music, I think the guys really didn't have a lot of time, so I think they started it within the last couple weeks. And we started with something very different. Actually, if you look up the demo on Poet, you'll find WOBBLE posted a VIP version. That was actually the original version, and we totally changed the drop. I don't remember exactly why, but I think we ended up with something that was at least easier for me to figure out what to do visuals to, or like what kind of visuals we wanted. So a bit of back and forth. Normally there's a bit more crosstalk there. Like we send previews to each other all the time. We're like always making stuff. So there's a lot of feedback, but I would say that in this one there was a lot less of that than there normally is, just due to when things came together. But normally it's just kind of really organic. We just talk a lot on Slack, and that's where most of the work is done. It's actually really unfortunate that the other guys can't really do visuals unless we're syncing together. And that's something I really want to rectify with the next bit of tooling that I want to work on. And I'm probably going to do a bunch of that on stream, actually, because I have a pretty clear idea of what I want to do, and I think it'll work. And I've been talking to some other guys with it, like other guys about it, like CPDT or Tropical Trevor, who are giving really good feedback. So I think that's going to work out really well. Anyway, I'm really glad you guys like this scene, by the way, because this is obviously it's one of the earlier ones, just playing with like extrusion and stuff. And this is originally where I came up with these like wireframe things that were in the earlier Venus scene, and just testing the meshes. So, but I thought this, I was so afraid that people would think this scene was too simple, but I just really liked it, and my girlfriend especially just loved how the scene looked, so I had to keep it. One of the earlier shots of this was, of course, this shot, which I had probably mid-February or something. Whenever I had the mesh compression, I had this shot, and I just love how it looks. I think it's so cool. And this is again, the idea when we first started out with this was to lean into low poly meshes and make the meshes sort of make it not cheap that they were low poly, make them look like that was super intentional, but then also take advantage of the fact that it's 64K. So it's kind of trying to lean into that limitation as much as possible was what I was thinking at the time. And I think we did less of that than I would have imagined we did eventually, but that's fine. Yeah, it's actually been amazing with as far as collaboration goes. Like I think so Hoffman and I started, like, me and Hoffman kind of developed a working relationship, and me and WOBBLE developed a working relationship kind of independent of each other. And then that all kind of came together in Logic Coma over time. So like I made commercial music with WOBBLE many years ago. And I made executable music with Hoffman many years ago. And all together it just kind of came together. Over time we just worked more and more and collaborated more and more. And I think part of that was Wavesaber, like the earlier builds and stuff. It was just so natural for Ian and I to collaborate there. And then it was so natural for WOBBLE to pick that up as well. But of course I always try to bring those guys in on visuals as well. Yeah, this is a deer head. I actually like that you didn't see it, especially here. It was meant to be like, it's not really meant to be super clear what this is. It's just supposed to look cool. So that's fun. Yeah, thanks, Aaron the German. I like the simplicity as well. I still wonder if this shot in particular is a bit too barren, but I just like it. I think it's cool. So the way that this works, I'll talk about how this works really quick, and then I'll talk about the mesh compression, I think. And the way that this works is we just take the low poly mesh, and every face gets extruded into sort of two sides here. There's the front face and the back face, and they both get extruded in the same way, where the triangle gets split into three separate triangles with this midpoint that sort of extrudes out. So it turns into this like diamondy thing. And whether or not it does that is determined by, like, we calculate the midpoint of each original triangle. So this is all geometry shaders. We calculate the midpoint of the original triangle, and then we do a plasma on that in X, Y, and Z, and then we get a glow parameter from that, which in the earlier shots is what you would see here. So I would just add to the emissive color. But then it was cooler if I added a bit to the color and used a separate color for the plasma. So like we make all of these a little bit brighter and change color based on 2 different plasmas. And then also we change the extrusion amount with that as well. Yeah, the eyes here and the eyes on the other head mesh. I did think of doing stuff with that, but in the end I just never got around to it. Maybe the next one. Yeah, I can, let me rig the camera back and I'll show you guys around this a little bit, and then I'll use that to talk about the mesh compression a little bit. So I think this one's called Dear Boys, if I remember correctly. Yes, it is. And I think this has this camera here, which, let's zoom in a little. I think we'll do this one here is easiest. And let's move this down a little bit too. Actually, we'll just translate up. That's probably easier. Just copy this. I think if I do like, is that gimbal locked? Did I do that in the right order? I don't know. Probably didn't. In which case we'll do this. You're seeing some shortcomings of our tool here, which is fine by me. Yeah, so this is the deer head more or less. We can go a little higher up too. So there's the back and the front of it. In fact, I can turn off the extrusion effect as well. So in Dear Boys Geom, we can just do glow is 0. It's the easiest way to do that. Or not. Oh, it needs to be back 3. Let's do distortion is 0. There we go. So this is the deer head. This is around 600 bytes, I think. In fact, actually, it shows it in the tool. We get some estimates here, at least. So the deer, yeah, about 660 bytes. There's a lot of numbers here, but this is the important one, is this estimated size, because it ends up being actually very accurate. So it's about 23, 24 bits per vertex for the vertex positions, and about a little under 3 bits per vertex for the connectivity information. So the indices. No, Rocket doesn't support sending data from the client. It would have been possible to make a lot of these effects with tessellation instead. Geometry shader was just easier and slower, as we'll see with some of the stuff. I want to move a lot of this to compute actually for the next one. Yeah, geometry shaders was literally just convenient. I knew that when we were going to do low poly meshes that I wanted to do deformations on them, and I knew that geometry shaders would be the easiest way to do that. Especially because I knew that I would want to do subdivisions on the CPU, which was a choice I just made for speed because it's a very simple algorithm. We use loop subdivision because we only support triangles, and we also only support manifold meshes, in particular 2 manifold meshes, which can give you a hint about which paper I implemented. So let's see. The subject here, I think this is the... Oops. I think it's the second subject. I think this is the one that is drawn here. I'm not entirely sure though. Yeah, it's this one. So here, this is the mesh with no subdivision. So this is the exact mesh that gets compressed. And then of course we can subdivide this, and this does loop subdivision on the CPU. So it's a bit slow when I change this parameter, but as you can see, it's, yeah, we get, I think, 2 soft meshes, which I knew we would get when I implemented this. So that's the other reason I wanted to lean into the low poly look. Anyway, in terms of the actual algorithm we use, we can see a couple parameters here. Well, maybe I should answer some chat things, then I'll get into that in a sec. Yeah, replacing Rocket has been on my list of things to do for so long, but there's so many other things that are more important. in our tooling that I need to do first. I think Trevor's also working on something with me for that as well, I should say. More cats and prods. I totally wanted to have like a lion mesh in here. In fact, I think I still have a lion in here that I was testing with a really complicated main. So this ends up being a couple kilobytes. And I also think I had I don't remember what else I had. Head Venus. I had a David head as well. That was in here that never got used. Some stuff. Anyway, in terms of the actual compression I implemented, the paper is called Near Optimal Compression of Two Manifold Meshes. This is the same paper that Rig of Farbrush implemented for Candytron a long time ago. And the only thing is that I just only supported triangles, which just made things a little easier and made the implementation a little simpler. The main gist of it is that there's a couple different observations. The first one is that most of your savings from the actual positions of the vertices is going to come from quantization. So in this case, I have this quantized max, which essentially determines how many bits are used per vertex. So if you do this at like 1023, you basically get no change to the actual mesh positions, no noticeable change. Where essentially, is that the one, Spaghetti? Oh, hey, that one's even animated. That was new. But yes, this is totally that paper. That's the one I implemented. And it works really well. However, there's actually a couple bugs in the paper, in the pseudocode. And I totally want to publish a blog post about what was wrong with it, because it took me a long time to debug. And I ended up having to compress a tetrahedron and like adding a bunch of like log prints to the algorithm and walking through it by hand in my notebook, like to go just step by step and figure out everything that was wrong with it. So it was a pain in the ass. And this is, I think, the second or third approach I tried. I tried some really basic approaches that were based on Edgebreaker, but simpler, in order to try and figure out like the simplest thing possible that would work well enough. And it ended up being that this performs so much better. It was so worth it. However, I don't actually remember what I was about to say. Anyway, for the meshes, we only end up storing positions in the triangles. There's no like UVs or anything. But the main thing for what we would call the geometry compression, which the geometry is the vertex positions, and then the connectivity is the indexes or indices. For the geometry, the main thing is quantization again. So the idea is that instead of doing 3 floats per vertex, we would do 3 integers, and we'd just like normalize them within a certain grid. And normally for a lot of meshes that have kind of an irregular shape, you want this number to be different per axis. And in fact, for the Venus mesh, that probably would have really helped. But in this case, I just did 1 for the whole thing. And the idea here, so like 1023 means basically 12 bits per vertex, and there's like no noticeable difference. Most of this, I think this was turned down to 63, which is 6 bits per vertex. But you can go down to like 31, and here I think you can start to see some deformation. You can tell that like there's more sharp edges here. And we can go down to like 15, which then we see a lot of problems with this mesh. And we can go to anything we want here, and it will roughly work. We can see some nans, so it doesn't quite work. But I can put this at like 100 too. It doesn't have to be powers of 2. It just kind of, you get the best results if it is. But yeah, so that's basically all we do for the geometry compression. The compression is actually driven by the connectivity. And in a lot of these schemes, you also try to like predict the position of the next vertex based on the parts of the connectivity that you're working on. In the end, most of those actually turned out to be worse with the meshes that I was testing with, which are inherently low poly, so they're pretty noisy in terms of the vertex positions. So there isn't actually a lot of value in trying to predict those beyond using a delta, which is what I ended up doing, and that ended up working really well. So I guess to kind of illustrate some of this, make a new paint document here. Say we have a really basic mesh, and we can make some assumptions, like we're going to assume that that it's a manifold mesh, which is going to help us out later. But for this explanation, you can kind of ignore that. It just again allows us to make some nice assumptions. So the idea is that what we're going to do is we're going to pick a seed triangle, and we're going to encode that first. So then we just output the first 3 vertices, and we know that they're connected. And then after that, we're going to go through each one of these vertices. And until we've gone through all of the faces that are connected to them in clockwise order, we're going to work on that next face. So from there, we know that, well, this edge has already been output, so this face needs to have this edge output. So we output that, and then we've finished this triangle and this triangle. And then we're going to keep going around in this circle. So then we're going to output this vertex and go here. We're going to output this vertex and go here. And then we're going to output, then this is actually done. So we're just going to fill this in. So it's going to connect all of that together. And then we go through the next vertex. So say it was this one. Then we go start outputting faces around that. Until basically we go in sort of these concentric circles until we've conquered the entire mesh. Yeah, it is counterclockwise, which isn't terribly important. The important thing is that the encoder and decoder are in total agreement about this. So some key points about this is that you're always trying to connect a new vertex to an existing edge or 2 existing edges. So the vast majority of the time, you actually never have to output a new vertex index. You just have to output a new vertex. So we kind of go along driven by these faces that are connected to the vertices and output new vertices to finish up these faces. On and on and on until we've conquered the entire mesh. And there are some special cases. Sometimes you need to connect to an existing vertex that you don't share an edge with. That's called a split. Sometimes you need to start a new triangle. We also call that a split in this algorithm. And there's a lot of other algorithms that are very good for this too. I know Looney's implemented a variant of edge breaker that was really small for 4K. But I'm generally very happy with this approach. It's not that much code. It's a bit more code than I would have liked, but it's not that much. And in fact, the implementation when I first wrote it in Rust ballooned to like 2.5K just for the decompressor. It's down to like 500 bytes now, if that. So it led to a bunch of optimization, which in total ended up saving like 4K of just bloaty code in our intro. So that's really nice. And we came in at like 300 or 400 bytes under the limit, so that was very much necessary. And that's even with our new packer. A lot of data in this intro. Anyway, that's kind of the gist of it. You really kind of need to check out the paper to really understand what's going on here. There's a lot of details about how it connects things and all that stuff, but I think I've explained enough of the gist of it. So then when we load that up again, we can specify how many times that gets subdivided, and that's just loop subdivision, which you can Google as well, which is also very easy to implement. So that's more or less all I wanted to say about that and this scene. Next is this one. So this is one of the earlier scenes actually that I was playing around with, and the whole thing is that I wanted to test like putting cubes on the points of the face mesh, and I actually still wanted to draw the face mesh as well underneath that and do some kind of cool coloring and stuff. I think I ended up just turning into something very different. So some earlier versions of this would be like this. And as soon as I got the cubes on the mesh, I was like, this is kind of lame. So I started adding these like bubbles, and the screen space reflections here are pulling a little bit of weight, so kind of approaching something cool. I noticed that certain shots, I really liked the shape of it, so I kept that. And then when I made these black, it was cooler. And then I just made them glowy. So yeah, well, dark second. This will be up on YouTube. Then I made them glow, and I took a lot of screenshots with that because I really liked that. Also, there was this side shot, which we never put in the demo because I ended up using that for the particles instead. And I thought that they shouldn't have the same shot, even though this is actually quite cool. I played around a lot too with like putting credits on the side of this, and it just never looked that great. But one thing I really like about this is that the screen space reflections catch the cubes on these little spheres, which I am really happy with. Anyway, that's mainly all there is here. These cubes are done by, again, generating a cube in the geometry shader, and the cube is oriented with, I think it's placed in the middle of each face and then oriented to kind of face a certain edge or something. I don't really remember how I did that. And then they're scaled by a plasma, and that's really all it is. And I think that ends up looking really cool. Then there's some like little glitchy things with the colors, but that's pretty basic shader magic, I guess. And I kind of wish I had done more with this, but I just like how it looks. This scene is, I think, the most complicated one. So this is the wax scene. And what I wanted to do is I wanted to do some fluids. And so this is actually polygonized. I implemented surface nets in the geometry shader for this. And I chose surface nets over, for example, marching cubes or marching tetrahedra because it produces not that much geometry. And at least from the perspective of shader, it's all a bit more local. Like you don't have the kind of tables that you need in marching cubes. So you do get slightly worse geometry, slightly chunkier geometry, but my hope was that I could make it higher res and kind of make up for that. But because I did it in a geometry shader, I couldn't really make it higher res, and I didn't really have enough time to dig into doing this properly in a compute shader. So I would like to do that next. That's one of the optimizations on my list just for fun. But it's fast enough, and it does the trick. And we were able to just, we don't actually have any fluids running in this either. It's all just SDFs, which we were able to kind of make look cool anyway. I'm glad you say that, Luna. I really tried to just play with so many things in this demo. I think the main thing that I wanted to do with this, though, and that you can really see in a couple of these shots, is that I wanted to do subsurface scattering. And it's totally an approximation. It's not perfect, obviously, but it does totally have that look. So you can really see it here on this edge as the light's kind of leaking through. This is a totally white material in this case, but it's that we have this green light that's sort of lighting through this. Now, the way I do that is actually really simple. I have a compute shader. There's actually a couple compute shaders here. One of them evaluates the SDF at every position on this grid. The other one will evaluate per cell whether or not there's an isosurface there, and if there is, it'll place a point there. And that one also will run through the SDF, and essentially it inverts the SDF and then calculates the same calculation you would do for ambient occlusion with ray marching, but kind of on the inverted mesh. And that gives you something close to essentially how thick the material is or how much it's occluded on the inside. We can use that for an approximation of how thin the material is, which is basically how much subsurface scattering approximation there should be at that point. So it's all kind of done in world space against the normal. So it ends up being really simple. I don't remember where I found that. But anyway, it ends up working pretty well. And then when we accumulate the light, which we do for the entire screen anyway, because I'm really lazy about light volumes, even though this is a deferred renderer, then I just calculate an additional screen space, or subsurface scattering term. And that works really well. Originally, I wanted to do depth peeling, but there was so much geometry here, and especially since it's generated by the geometry shader, we're already like wasting a lot of bandwidth anyway. So I didn't want to push that through the GPU more times than necessary. So that's why I came up with a solution like that, rather than like depth peeling, which would have given us actual thickness in view space. Which is another thing I would like to play with later when I move the actual geometry generation to a compute shader and do indirect draw instead. But yeah, I like that solution because then you get a constant number of steps to calculate the thickness, and you still get a relatively convincing effect. And it was totally inspired by some other technique I found. I don't remember where they were doing that for something in Unity. Cubicle marching squares, I guess that sounds cool. Probably look at that as well. Haven't considered if we can do caustics with this. I mean, it really just sort of approximates material thickness. So I suppose you could. I haven't really played with it. It's a total hack, but I think it has the right look. And a lot of this geometry too is like chunkier than we would like. And I think part of that is just that I'm not using the greatest. I use center of mass to figure out the points that are generated for the isosurface for each cell, which is not great. I could use some like Hermite approximation or whatever, but like they do with dual contouring. But I think this works well enough, and it actually kind of makes it look noisy in a way that I like. It makes it look almost more fluid. So the SDFs here are actually really cheap. In fact, I kind of want to break those down. Let's see. So this SDF has some parts. I just want to find like a shot where that really kind of shows what it is. And then I can kind of break this down. This is good. Okay. So the SDF here is actually really basic. It's in wax and the SDF here. So there's a few different layers or a few different SDFs that I use here. I think, yeah, that's the one. Ignore that. Let's see. Let's move some stuff around here. So I can show you this. So this is the SDF. There's some basic components here that I'll sort of add progressively, I think. It's that one and that one. That one. Yeah, so we'll start with this. So what this is just like essentially a sphere, but I put that into a sinus so that you get kind of these different layers that sort of go out radially. And I'll also remove this, which I'll get to in a second. And then I add some FBM to that, which kind of gives you this look already. So that I think that pulls a lot of the weight for this look. So we'll get back to that in a second. Also here I add this bottom part, which also has some FBM to kind of make it look like it's sort of the surface of a fluid, because I really wanted to do fluid here, even though I didn't do actual fluid. Then I do these cutouts, which is this typical slice kind of thing. And there you can see sort of the different layers there. And then with this, just twisting it does a lot of work. So around the y-axis, I just do some twist based on y. So for example, I can make that way more or way less. Different kind of twisting. And then of course the FBM on top of that. So it's just those few things put together and you end up with something that's actually pretty nice. Again, as typical with Logicoma stuff, simple things put together. And then of course there's those black spheres from the headshot that's just, they don't even move. They're cheap. And then the material thing here, this is just done in the pixel shader. You take that final position and then do a step function with it basically and just blend between two materials. The screen space reflections here do a lot of work in terms of getting this look, which I'm really happy with. That just kind of worked out. And of course, when you have that kind of reflection tech, you want to like change the roughness of the different materials so the reflections actually look different. So I'm pretty happy with that. We're actually getting to the end of the demo already. The end part is just the credits, which I totally ripped off of a really lame looking movie that's going to come out soon. I should probably show some more work in progress shots of some of this stuff. In particular, the fluid thing kind of came together. I like some of these work in progress shots. In the meantime, I guess you guys can just start asking some questions because, yeah, I'll just answer those and then we can. I'm talking a lot. Yeah, I use the diagonal stuff all the time. All the time. So this was like the earliest thing that I did with the surface nest. This actually just generates cubes based on isosurface. That was the first test. This was the first geometry I had. It looks pretty chunky. But that also has to do with the SDF I did, which is pretty much just a noise function, I think. And at different angles, this already kind of looked cool. So I might use that for something else too. Here, I think here too, I also have flat shading still. And then here I start doing the smooth stuff, which is a bit better. Sorry, scam taken. No, the credits are not PNGs. We pack fonts and then we render bits of text to textures. So yeah. And then here I did the twist thing. So I think this is more or less starting to be the SDF that you actually see in the demo. I really like how this looks. I think that's really cool. And then here I added the bottom part and started playing around with the lighting. Again, you can really see how this is starting to shape up. Here I added that green light. Here I added the black balls just to add something else to it. Here I start making the background dark. And then here I did the first subsurface scattering. So that's the difference, basically, with and without. It does quite a lot, I think. And I think it looks really nice. Here you can really see, I think this is a good look. But I was really just trying to bring out the subsurface scattering. And then here I added the purple and red gradients that I've been talking about the entire time. And I think I blew them out a lot in this scene, but it works. And then some test shots for this stuff. That's more or less it, I guess. I'm getting really tired of talking. Oh yeah, here's a test shot with just balls. I think that's cool. There's one shot I'm really kind of missing here. Maybe I just had that on Snapchat and I won't see it ever again. Depth of field. Oh, that's implemented from several things. Mainly I think it's Crytek graphics gems 2013 slides, and there was a Battlefield slides from 2014. It's all by Thiago Sousa, and it's essentially the same stuff that's in Doom. But of course we support different kernel shapes. I think it's Crytek graphics gems. I think that's what the paper was called. It's those slides, and there's a lot of information like tweaking that stuff too, but it's essentially that technique. And I wrote that back in 2016, I think, for Elysian, and we haven't really changed it since then. Also, for the far field, we end up doing everything in full res because we have the frame budget for it. And that flickers a lot less. And the materials and the lights here are really basic PBR stuff. In fact, actually the lights, they're spotlights, and I just treat those as point lights with some attenuation based on like the cone of the light. But I actually don't attenuate based on the distance from the light, which is kind of convenient. Cheap, but it looks nice anyway. I don't think I'll ever open source the demo itself. The tool at some point I would really like to, but not in the near future. It's just not going to happen. Is there a trick for moving shots around in Rocket easily? No. I wish there was. Just pain. You just have to accept the pain, or make a better solution. Your call. Either way, it's pain. Pick your pain. But yeah, I think in this demo, I really tried hard to push myself a bit here, in doing new tech and especially doing more complex stuff on the GPU. And I will definitely be doing more of that stuff. Not at all done pushing my own limits. So the next ones might be similar. They might not be, because I want to push myself in many more directions still. I think this one, LJ at the party told me that this was a lot like Trash Panda 2.0 or maybe 3.0 because there was a lot of new tech, but I think that's actually somewhat accurate. It's the same renderer, and I think that's the first time between demos that we've used the same renderer. Like Elysian had a polygon deferred renderer that's completely different from this one. Engage had a ray marcher. Iota had a quad. Trash Panda had a deferred renderer, and this one has the same renderer with a lot of bug fixes. Which part of the OpenGL graphics pipeline do you like the least? All of it. Takeaways from dabbling in compute so far. It's annoying to calculate workgroup sizes and how you should dispatch things. Compute shaders are awesome. I love them so much. Generally, they give you an interface to the GPU that you always wanted. You don't have to kind of shoehorn things into a rasterizer anymore. So I'm pretty happy about them. Stormy says, what do you use compute shaders for? In this demo, we use them for particle updates. We use them for part of the polygonization process for this wax effect at the end. I think those are the main things we use compute for in this demo. I want to do the full polygonization process for this effect on there later, but that'll be in another demo or something else. Yeah, the workgroup stuff's just inconvenient. To compress images, I would recommend anything like what JPEG's doing, like wavelets and some kind of DCT. We might look into doing a custom audio codec. I think I've talked about this a lot, actually, for Wavesaber to get around some of the GSM issues. And also because I think we can do better, which will use a lot of the same ideas, just with different dimensions. But yeah, I think that's probably the most annoying thing with compute is that you have to determine like work group sizes, and it's kind of arbitrary what you choose. And you need to find like a way to distribute your workload that kind of fits that nicely, which is kind of a detail that would be nice not to think about, but obviously makes sense why you would have to. For example, with this particular scene, you can have, I can change the, let's see here, if I open up the operators again, I can change the resolution of this. And again, this should be X, Y, and Z should have different resolution stuff, but I think I only did I think I only did one dimension for the whole thing. Where was it? This is a big project in terms of the operator graph, which is definitely something that I want to address in the next iteration of our tech. Yeah, another light. It's kind of fun. Anyway, here. So it's 128 here. This is 128 by 128 by 128. So this goes down to 16 is the lowest because my workgroup size is 16 by 1 by 1, I think. Or maybe it's 16 by 16 by 1. I think that's what it is. I can do like 32. Anything that's divisible by 16, I can do here. And I really wanted 256, but it's slow. So I'm going to have to revisit that one. Maybe it's too slow. I don't know. I need to upgrade my graphics card soon. Anyway, so figure that one out. Any issues to look out for the surface nets, paper, and resources you used? I actually had a hard time visualizing what actually gets connected with surface nets. It ends up being really simple. Let's see if I can distill this and if I remember it correctly. It's like deceptively simple. So with surface nets, you can do it in 2D. So let's say this is marching cubes. You would have these vertices and these edges that connect them. And of course, this would be in some kind of mesh configuration. Look at me using high performance computing terms. I totally don't make brains for a living now. Some kind of like mesh configuration. And with like marching cubes, you kind of figure out where the isosurface should be, like roughly something like this. And then you would calculate these edge points and you would triangulate this per cell. So you're sort of, the cells become faces and then the edges become vertices. Surface nets is a dual to this. Like you produce a dual mesh to this. So you actually, every cell becomes a vertex, and then the edges actually become faces. So in surface nets, you would generate essentially 4 vertices here, because 1 for each cell, and then you would connect those based on adjacent cells. And it's that connection that's how you connect them that actually took me a while to realize. But essentially what you can do is you can look at like, if you imagine this in a cube, it's going to be really hard to draw, so I'm just going to say screw it. But you can basically look at which edges along these axes sort of cross the boundary. I'm actually losing what I'm thinking a little bit, but it's actually this one. You can think of this point in the middle as like a pivot, and you can detect if this vertex and this vertex have opposite signs with respect to the isosurface, then you know you're going to connect these adjacent cells. It's something like that. If you draw it out, it becomes a lot easier. But it's simpler than you think. It was my experience. And I wasn't the only one. Someone on Stack Overflow went through exactly the same thing, and then I didn't understand it from the answer that the person gave. So maybe I'll blog about that too. I had to draw a lot of pictures, but once I drew them, it made a lot of sense. Yeah, GPU I'm using is a GTX 1070. I can't do a 64K in Unity, but as PSNF points out, Quadrip says yes. Yeah, what Tropical Trevor says is basically it. Yeah, that's exactly it. So like you can generate this where you just put vertices in the middle here, and you get like a Minecraft look, but you still get the same isosurface. But with surface nets, you just place these vertices somewhere a little bit better, and like dual contouring does the same thing. But in fact, dual contouring is all about that placement versus just surface nets. So in this case, we did like the naive approach, which is find out where the edges cross the isosurface like you would in marching cubes, and then take center mass of those edges. And that's where we end up placing the points. And that's the easy way. And so we have one compute shader that evaluates the SDF at all these points. We have another one that then figures out these points in the middle of the cells for relevant cells, and also outputs cell data so that a geometry shader then goes and takes as input all of the different cells, and for the ones where they're supposed to be geometry, or rather ones where the isosurface cross, then we actually do the connections. Yeah, I'll have to check out cubical marching squares. That's definitely a technique that I missed. But I had a lot of fun implementing that. It'll be more fun moving that to pure compute, which should be a lot faster. Because actually, if we look at this here, we can see a little bit of the profiling. Here, the wax compute is actually quite expensive. I don't remember it being that expensive before, so maybe I made it slower revision. But this is all of the compute for both determining the SDF and creating the cells that would contain geometry. And the rest of this frame time is going to be generating and drawing the geometry to the G buffers. And then we can see that is a little bit more than that for the two different lights. These are actually cheaper in terms of generating the geometry. It generates it again twice, once for each light in this case. But of course, it outputs a lot less data because it only outputs the depth. So there's a lot less bandwidth coming out of the geometry shader. So that ends up being faster. So that way we can do two in about the same time. But I'm guessing that if we did this in pure compute, we would generate a lot less geometry. And I think this would be about there instead. And then these would be a lot cheaper. That's my prediction. Haven't done it yet, but I want to try it. Stormy said, are there any interesting graphics related papers, resources you'd like to recommend for reading? I mean, I've got a few in my backlog. I'd have to look them up though. But I'm seeing some really interesting stuff with AO and screen space reflections, and a lot of these things, as people are starting to apply more and more temporal filters on top of them, that seems to be getting a lot more interesting. Yeah. I probably should say more about the music, but I'm getting really tired. I might leave that for Hoffman for another time. But the main things that we did there was we reorganized a lot of data to make that a bit smaller and make things compress a little bit better. At the very end, Hoffman still had to reduce the size of one of the symbol samples that we used to gain some more space for the extra sync that we definitely needed. Yeah, temporal stuff is going to be annoying, but I got a bit of crap from some guys about aliasing, and I do actually want to look into that. So I'll spend some time with that, but I don't know how much. We'll see. There's so many things I want to work on now. Yes, and YX got me to fix the timing code as well. That was a couple hours on Saturday that we should have been syncing, but I think that was worth fixing. Worth taking the time out to do that. My PM might argue otherwise, but I'm pretty happy that I did that. I think, though, again, I'll say it again, the thing that I'm most proud of with this demo is that I really pushed myself to do a lot of tech, and to just make things that were really colorful. And I'm really proud of the result. I'm glad you're happy with that, YX. I'll clean it up and get it on master as well pretty soon here. Got a lot of PRs on there to go through. Yeah, no problem. I enjoy doing these breakdowns, and I'm glad other people are doing them now too. It's really cool to see. Definitely felt like a PC notch demo 64K. I'm happy about that. I think that's cool. Orange filaments look gorgeous. Thank you so much. See you, Trevor. I won't stop being proud of this. Thank you so much. This, too, is actually kind of an accident, I should point out. The screen space reflections on the balls, too, is actually quite nice. It definitely accounts for some of the flickering, but it was kind of nice that that just worked. And for the screen space reflections, because that was a new thing I did too, I do it like a DDA algorithm where I actually trace pixel by pixel along the reflection rays in order to get better coverage of which things you're sampling. And then I have like a stride, so I actually skip every other pixel or something in the final demo. We meant for that to be parameterizable per scene, but I don't think I actually ever tweaked that. Logical intros are 85% more demos than others. I'm not sure what that means, but I'll take it as a compliment. And these rings are also reflective slightly. It's just hard to tell because their albedo is so low. But that's fun. If nothing else, I hope this didn't seem that 64K. Your mileage may vary. But yeah, the main thing is that I pushed myself. I pushed myself to learn about mesh compression. I pushed myself to make our packer actually beat Crunchy finally after 3 years. That was a huge moment for me when that actually worked. Pushed myself to learn a lot of this compute stuff as well. Lots of stuff. So I'm excited to continue sleeping this week. See you later, Mixlo. Thanks for hanging out. Appreciate it. But yeah, if you guys have any more questions, fire them off now. Otherwise, I think we might be done. Spaghetti says, how do you decide what's parameterized and what gets hard-coded? I start with hard-coding everything and then parameterize stuff as we need to. That's the answer. Mala said, are packers going to get any better? They're not going to get much better. Definitely not. Mostly what my packer capitalizes on mainly two things. One of them is the fact that computers did get a lot faster in the last 10 years. And we were able to take advantage of that to implement more accurate models, have the compressor look at more contexts, and mix a lot more context as well. So a little bit of a larger neural net than what Crunchy has. That's the first thing, is that we're just able to take advantage of more CPU and more memory. The second thing is that I did a new executable modeling technique, which I actually haven't seen done anywhere before, where rather than, for example, reordering the bytes like Crunchy does to force sort of vertical correlation or vertical or horizontal correlations of the data, I actually leave the data in place and split it on the fly. So my compressor is actually able to look both as if we had split it into separate streams and the original to find patterns, and it tends to work really well. Like a few kilobytes better. And there's room for improvement in my packer, definitely, and I'm pretty sure there's other approaches as well. There's some machine learning stuff I also want to take a look at, but from what I can tell, it does a little bit worse than the custom solution that we have now. But anyway, are they going to get better? Probably not by much. Probably not by much. At least not within the same kind of time envelope that we have. Because like, I could shave another 2-3 kilobytes off of this if I wanted the user to wait 40 seconds from the time that they double click the intro to the time the dialog box comes up, but that's not going to happen. So within roughly the same parameters that Crunchy operated in 12 years ago, we get better compression now because computers are faster, and so we're able to push more models through it. And that's not going to keep happening, and it's not really a parallelizable problem unless we have a lot of separate memories as well, because you're essentially bandwidth bound on most of these kind of models. It's a lot of very hashy kind of memory access patterns, which are really bad on cache. So you're almost always memory bound, and you're doing a lot of compute per bit. So it's very slow. And versus something like Crinkler, like we kick Crinkler's ass like really hard because Crinkler is also optimized to have an extremely small unpacker. And in fact, my packer now has 2 stages where the first stage actually decompresses the actual decompressor, and then the second stage decompresses the data. So it's pretty intense. But again, I think there's room for improvement there still. Like I know I can reduce the second stage decompressor a bit more, and I can probably tweak the models a bit more too. So no, it doesn't sound very cache money. So there are a lot of like small things where we could probably gain a few hundred bytes more, but I don't think we're going to see a lot of dramatic improvements from there. I really don't. In fact, I think Squishy represents probably the best, at least at this size of data. It's the best compressor there is, and some of the more interesting executable modeling stuff that I've seen, at least. Like I said, I haven't seen a similar scheme to what I'm doing done. And I've definitely looked. But I could always be wrong. And I would actually love to hear if someone knows something that I don't about that, because anything's interesting. And if we can do better, then I want to. Yeah, obviously each one of those stages is very diminishing returns. I spent a lot of time on that first decoding stage too, like fighting versus the Windows compression API, and I ended up making something custom that won. So that's kind of cool. And there may be other approaches that I haven't considered at all, but at least for what seems to be known in this area, there aren't silver bullets. And if things are going to get any better, it's going to be very diminishing returns. Despite that, I would still recommend people just to make their own packers because it's cool. But you're probably going to get not very good returns. On the cube, blue cube plasma head, I straight up stopped seeing effects, just lost the motion graphics and goodness. Awesome. Thank you so much. I'm so happy you say that. That's totally the goal. I hoped that people liked that about the look. Is there a good 64K packer for Linux? Not that I know of. I'd be happy to share a lot of the knowledge that I've accrued of this, or for this, if someone wants to make one. I think I've mentioned many times, but I have a series of blog posts that I'm still working on. I will probably be working on it for a while, but they detail, they go over the packer in very fine detail, so almost enough to just implement it yourself. Yeah, ProSign mentioned something about wanting to do that for Linux, but Black Pond, how do you manage your time to be able to dedicate so much to the demo scene? I don't know. I really don't know. My answer is not very well. I've given a lot of credit to my girlfriend for this production, actually. Especially because she's very supportive of me doing this stuff. I mean, she comes to demo parties too and has for a lot of years, so she really does a lot in terms of kind of keeping me a bit more structured. Like she's the reason I started this in February, and not 2 weeks ago. And boy, am I glad that's the case. Worked out a lot better. She also deserves such credit for Trash Panda and Bros Before Foes. By the way, Sir Skidmore, thank you so much for the bits. I'm so sorry that I didn't thank you for that earlier. Yeah, sleep, work, demo, repeat. So true. People at work were actually very supportive of this. They were very friendly about this and congratulatory about it, and I really appreciate that. Again, the feedback on this demo has been overwhelmingly positive, and it really means a lot to me. Like, I've been in the demo scene a long time, but only only in the last few years with Logicoma, which in a lot of ways was a really concerted effort of just like, okay, we're going to do this the best that we can now. It's been very well received and very much appreciated. And I really can't thank the demo scene enough for just for that, just for appreciating the stuff that we're putting out there. And we're having a lot of fun doing this. And I'm so excited too to see a lot of these newer sceners come on the scene and make really good stuff too. It's hard to mention everyone by name, but like Moliv and YX and CPDT are all very much people who, as I mentioned before, are gonna kick all of our asses later. So I very much welcome that. And it was funny because in YX's stream, there was a comment about there's some heavy hitters like Conspiracy, Mercury, and Logicoma, and I was like, what? I'm in that group now? And I mean, I guess it's extremely flattering. I really appreciate you saying that, first of all. I really appreciate you saying that because like we're working really hard to make this happen, and I really appreciate that that's being seen and being rewarded in that way. At the same time, I'm like, I don't really know how I feel about that. But yeah, thank you so much. Thank you so much. And thank all you other people for agreeing with that. I'm getting quiet and a little bit emotional about it, to be honest. But I'm very happy about that. And I hope, like, I think we have several more 64Ks that we're going to make. I guess that's true, PS. And again, thank you to everyone who's involved in the Meteorics for making that happen as well, because we're very much appreciative of that. We really like the Meteorics, even though we don't sign up to like be jury or anything. It's just we really appreciate what they're doing and are very, very happy to have received those awards. Yeah, I guess that helps too, CBDT. And definitely we welcome more people to make awesome demos, 64K or otherwise. It makes me so happy to see cool stuff, so keep doing that. You guys keep making cool stuff, and I promise to keep at least pushing myself. So I promise that Logicoma will surprise you yet again. Thanks for saying that, Luna, and you too, Alkama. Thanks, Fernando. Really appreciate it. I would also comment because I think it was CPDT that came in and asked me like how I felt about. I'm so sorry, I'm blanking on your new group name. YX and Subi. It was why can't I remember this? Polarity. Thank you so much. Polarity. Sorry about that. I really like the new group name, by the way. I'm just not used to it. Anyway, someone mentioned that like, yeah, CBTT said like, how do you feel about that demo being so clearly inspired by your stuff? And I was honestly surprised to hear that. I'm not bringing it up because I feel that way at all. I'm bringing it up because I actually feel like that's not the case. What I saw in the Polarity demo was a lot of your own voice and I think your own style that will continue to be developing and becoming even more unique. I mean, yeah, it had chromatic aberration and glitch, but what demo doesn't, you know? So like, and it was also very, very sync driven. So I think that also maybe played into that. But my point is, I just didn't really see that. As Hoffman says, like there was a YX and Subi production. So I found it weird that people said that. And I definitely hope to see more releases from Conspiracy and Mercury as well. I know Conspiracy are working on something really cool, so I'm really looking forward to seeing that especially. and all the other people who made awesome intros. I really liked Branch Fizzies. I really liked Tropical Trevor's. I really liked the Brain Control one. Basically, all the demos in the compo were really cool. And in several other combos were also awesome. So, very happy about that. And I'm also very happy to have been able to I guess contribute more technically to the scene too with the Packer and the synth. I'm really happy that people are using those and that they're using them well. And again, props to Ian for really putting that stuff in people's hands. I think he's the one who gets most of the credit for that. Also, I just realized I might have referred to YX using the wrong gender pronoun, and I really apologize for that. That is definitely not something I mean to do, and I'm terribly sorry if that's something I did. I was also delighted with how many entries there were. It was a great compo. Yeah, Hoffman was a bit busy. Yeah, I could use some more PC demos. There's definitely room for improvement there. There were some great ones in there too, but overall, I think we could see more. And obviously, Amiga was super strong. I had a very emotional experience watching the TBL demo. I was very happy to see that. And of course, anytime Branch, really happy you guys used it. Yeah, we didn't have any stickers. We planned on printing some. We'll get some later. Unfortunately, we might have to ship some to the AU, but we'll get there. Alcama said, now the 64K scene needs forward of the floor a la MFX coolers. I so much agree. EB Next, yeah, definitely come to Revision if you can. It was a great party. And I'm very much looking forward to your 64K at Assembly Branch. That'll be awesome. Mala, thank you so much for the sub. I really appreciate that. Yeah, bring him to SIGGRAPH Asia. That'd be cool. Yeah, I would love to see a proper Techno 64K. Would love to see that. And I also will say that there's so many things. Yeah, Hoffman. Cough, cough. Oh, man. I'm just going to point out that you guys have no idea how much unreleased stuff that we have. And I'm so happy about that. I love Logicoma for that. We have so much stuff that's just in the works all the time. Anyway, I'm so inspired too after this year to make a lot more tech, especially like, yeah, I have this operator graph thing, but I really want to add like more higher level tools on top of that. And I think I'll work on that on the stream. How far into Brainworm did you figure out who it was? I feel like I knew right away. And I'm not sure why I knew that. If it was something on the beam slide. Maybe it's... Yeah, I think that's what it was. I think it's because you thanked CPDT on the beam slide that I knew who it was. Because I remember you asking about that on the Wavesaber Slack. So I actually think I knew right away, and that's why. Yep. Yeah, congrats on the new group name. I think it's cool. Please do more stuff. There's clearly a lot more 64Ks than you people. So get them out. And keep doing streams. I'm really happy that other people are doing those too. In fact, I think Flopin's stream is happening at the same time. And I'm sorry that those schedules conflicted. That's just how it's going to be, I guess. That's perfect, Ska. That's how it starts. But yeah, I highly recommend, if you guys haven't already, go watch the Revision 2019 64K compo live video, because it's so much cooler with the cheering. It's not nearly as cool as being at the party, which I definitely recommend you do, and sit with all of us, and it's awesome. But if you can't do that, go watch the video. It's pretty great. And watch several other ones too, like the Amiga demo one especially, I would also recommend. Several others, but definitely watch the 64K one. It's really good stuff. But yeah, I think I'm going to go. Thank you guys so much for hanging out. And again, thank you so much for the very positive response about this demo and all the stuff that we've done. I'm extremely proud to have made this stuff, and I'm extremely happy with the results. I had an amazing revision, an amazing Easter, and I know all of you guys did too. And I look very much forward to more of these in the future. Even though, small spoiler, we probably won't have a 64K for next year's revision. And you will definitely see why. Anyway, thank you guys so much, and I'll see you next time.